All right, you guys, this is the second part of the Chapter 10 review. Looking at number 35, we can match that picture to our picture number 2 on our formula chart, which is the top middle of our angle. And it says the angle is equal to half of the arc that it forms or eats. In my picture, angle 1 eats this arc right here. So I can't just half 118 because 118 forms the other angle. So what I do know is that those two arcs together total 360. So I'm going to do 360 minus 118, which comes out to 242 for the arc that angle 1 eats. So now if I'm going inside the circle, I'm going to take half of that value, so 242 divided by 2 comes out to 121 degrees. 37 is a tricky question that was in our notes, as well as our homework, as well as our quizzes. So it's a good question to know. When you look at this, we have two essentially pulleys or circles. And it says that AB is tangent to our circles, so that's why those 90-degree angles are there. When you look at this problem, the first thing you want to do is draw a rectangle that is parallel to the 20 units. Sorry, drop my calculator. So I am going to I'm going to do it the other way. So I'm going to draw a parallel line to my X, starting from B. Okay, and those are the same value because opposites are going to be congruent. Same goes for if this right side is 6, then this left side is 6. And since that radius is supposed to total 8, that leaves me 2 left over for that top part of the triangle. So if I look, I have this right triangle on the very, very top where the hypotenuse is x, so that's my C, and I can do 2 squared plus 20 squared equals x squared. So that would be 4 plus 400 equals x squared. And combine your like terms is 404. And to get rid of that squared term, we're going to square root both sides. And so x would round to about 20.1. That looks like a 7, sorry. 20.1 units. All right, number 39. Okay, so we've got essentially three types of problems. One of them is from a formula chart, directly from the formula chart. The second one is a find the radius and use Pythagorean theorem problem. And the third one is the party hat, where when you wear a party hat, both sides of the party hat are going to be the same. So if this is our face, right, I'm wearing a party hat on my head, a party hat on my left cheek and my right cheek, and all the party hats have to be the same on both sides. So if they've given me that QY is 3, that's part of the hat on my head. So that means the other side of my hat is also 3. They've given me PZ is 4. That's the party hat on the left side of my face, so I can say that the pieces that intersect are also going to be 4. And RZ is 7, so that means this hat on the right side of my face would be congruent. They're both going to be 7. And it asked me to find the whole perimeter. Well, I'm really bad about keeping track of which things I've added together, so I like to find the total of each side. 4 plus 3 is 7. 3 plus 7 is 10. And 4 plus 7 is 11. So I really want to do 7 plus 10 plus 11, which comes out to 28. And since my units are meters, I need to make sure I have meters on that. All right, number 41. We have this pie chart where we want to find the central angles and the number of students making A's. Anytime I give you percents, I want you to take the percent and multiply it by the total of whatever it is you're talking about. So for central angles, angle measures, the total angle measures in a circle is 360. So the 360 is the total part that we're using. So to find A's, I want 25%, which is 0.25, and I want to multiply that by the total of angles, which is 360. So 0.25 times 360 comes out to 90 degrees for A's. B is 40%, so I want 0.4 times the total 360, and that comes out to 144 degrees, which makes sense because that's a little bit bigger than the section that A was. C is 30%, so I'm going to do 0.3 times 360, which comes out to 108 degrees, which makes sense. That's a little bit smaller than B, but a little bit bigger than A. And then F is 5%. 5%, when you move that decimal over, you're moving it over 2 to the left. So moving it one would be 0.5, moving it another is 0.05. So we want 0.05 times 360 for the F's, which comes out to 18 degrees. A good check, make sure that 90 plus 144 plus 108 plus 18 adds to 360, which it does in this case. All right, for the second part, you want number of students. We still want percent times the total, but this time the total number of students is 120. So we want a percentage of 120. So for A's, that percentage is 25%, which is 0.25 times 120, which comes out to 30 students. And then for B's, that would be 0.4 times 120, which is 48. For C's, we want 0.3 times 360, oh sorry, not 360, I'm reading my own writing. 0.3 times the total of students, which is 120, which comes out to 36. And then for F's, we want 0.05 times 120, and that comes out to 6. And when I double check, all 4 of those should add back up to 120. But just remember, it's always the percent times the total. All right, 43. Okay, on 43, what we have is, there are actually several ways to work this. Let's start with the main idea that these two arcs are congruent. Well, if T is the center of the circle, that means that 4x minus 2 and 78 are both equal. So I would say that 4x minus 2 equals 78. And I'm going to add 2 to both sides, which gives me 4x equals 80. And when I divide both sides by 4, that gives me an x of 20. Since these both are equal, I know that this angle is 78, and I can plug my 20 in for my x to know that that angle is 20. My final goal is to find UTW, the angle. Angle UTW is made up of a 78 and another 20, so I want to take 78 and add 20 to that, which gives me 98 degrees for angle UTW. All right, number 45. When you look at this picture, those congruent arcs here, congruent angles tell us that the arcs are congruent, so they're both a value of x. And 112, x, and x, all 3 pieces should add to 360. So if I take the total, 360, and subtract out the 112 that we have, that leaves me 248 degrees for both of these arcs to share equally. So I want to see how much each arc is by dividing 248 by 2, which leaves me at 124 degrees for both of those pieces.